In the endless darkness of the galaxy, an ancient traveler approaches our solar system. It was born in the early days of the Milky Way, older even than our sun. It departs, carrying the secrets of the cosmos, leaving us with a timeless question. Are we alone?
Out in the endless dark between the stars, where light can take tens of thousands of years to arrive, strange travelers sometimes appear. They don't belong to our solar system, nor do they obey the familiar pull of giants like Jupiter or Saturn. They pass through space like phantoms, with no home to return to, carrying stories written in the earliest days of the Milky Way. One of these visitors has just stopped by, bearing a cold, mysterious name: 3 Atlas. When astronomers first noticed an unusual object slipping into the solar system, they couldn't immediately believe it had come from beyond. Most orbits here follow closed ellipses bound by the sun's gravity. But Atlas carved a very different path, a curve that would never return, like a brief wave before it drifted back into the void. Its speed, about 58 kilometers per second, was more than enough to escape the sun's grip, more than enough to prove it carried an interstellar passport. That meant it wasn't born of this system at all, but had traveled here from some distant place, maybe even from the ruins of a star that died billions of years ago. What makes 3I Atlas remarkable isn't just that it's only the 3rd interstellar object humans have ever spotted, after Oumuamua in 2017 and Borisov in 2019. It's also what it carries in its chemistry and its age. Borisov hinted that comets could form in many different planetary systems. Oumuamua sparked debates with its odd shape and puzzling behavior. Atlas opens yet another door. Evidence suggests it may have been born when the Milky Way was still young and poor in heavy elements, an era when planet formation was thought to be almost impossible. Its existence is like a whisper from deep time, challenging long-held assumptions about how worlds come to be. To grasp the weight of that, we need to zoom out and look at the history of the galaxy itself. Stars, like people, have life cycles. The very first stars were made almost entirely of hydrogen and helium, the simplest elements left over after the Big Bang. Only when those early giants died and exploded, scattering carbon, oxygen, iron, silicon, and more, did the universe acquire the raw materials for rocky planets, and eventually life. For a long time, scientists believed that only after the galaxy enriched itself with metals, about 8 to 10 billion years ago, could comets and planets form widely. Yet Atlas seems to have emerged from the lean years before that enrichment, showing that even in scarcity, nature found a way to weave matter into complex bodies. And then there's the detail that makes Atlas almost sacred to scientists. It carries water, not just random traces, but jets of vapor and dust escaping as its ice melts in sunlight, ice that has lain untouched for more than 11 billion years. That vapor is more than a spectacle, it's a record. Water is the essential ingredient of life. In our solar system, water has been recycled countless times through generations of stars. But the water in Atlas is pristine, unchanged since it first formed. It may be the oldest water humanity has ever had the chance to study, like a window cracked open to the youth of the cosmos. Thinking about its journey feels like reading a saga written outside of time. Perhaps Atlas was once part of a young planetary system, until a violent gravitational tug from a star or giant planet flung it into exile. From that moment on, it became a wanderer without a center, without a home, facing only the cold expanse ahead. That voyage could have stretched across billions of years, through dusty clouds, stellar nurseries, and dark voids empty of even a single grain. All the while, it was bombarded by cosmic rays, frozen nearly to absolute zero, yet it preserved a core of ice holding secrets no telescope or book had ever recorded. Atlas, then, is not just a lump of rock drifting by. It is more like a message from the dawn of the Milky Way. It came here without intent, simply a consequence of celestial mechanics, yet for us it carries immeasurable value. Every photon reflected from its surface, every spectrum captured by telescopes, contains clues about the past, about how the first matter assembled into worlds. And hidden in those clues is a question humanity has always chased. Can life take shape elsewhere, under conditions utterly unlike Earth's? The fascination of Atlas lies in its mix of the familiar and the alien. It vents water vapor, like comets we know. It carries dust and organic material, like countless asteroids and comets closer to home. But it comes from a system that may have vanished billions of years ago, stamped with a chemical fingerprint completely different from our own. In it, we see both a mirror of ourselves and a glimpse of something wholly other. Within a human lifetime, spotting an interstellar visitor is astonishingly rare. Most of us will only ever hear of one, maybe two. Yet across the span of the galaxy, millions or even billions of such travelers have likely passed through unnoticed. It's only now that our instruments have grown sharp enough to recognize them. And somehow Atlas has arrived just at this moment, when humanity is mature enough to see, to understand, to ask the bigger questions. So when we speak of Atlas, we're not only talking about astronomy, we're talking about ourselves, about the longing for origins, the endless curiosity for the sky, the strange mix of humility and awe that comes with realizing how vast the universe truly is. Atlas doesn't answer those questions. It simply knocks on the door, inviting us to step outside and keep searching. And sometimes that single invitation is enough to change the way we see the cosmos and ourselves forever. If the opening took us into the world of ancient wanderers, then the second story is about how humans, with increasingly sharp artificial eyes, truly uncovered Atlas. Because in the vastness of the cosmos, spotting a tiny object drifting through the void is far from obvious. It's like trying to find a single grain of dust floating in a desert filled with billions of others. And yet, we did it. Not through luck, but thanks to a modern observation system built precisely for this purpose. The ATLAS network, short for Asteroid Terrestrial Impact Last Alert System, is one of those tools. The name may sound a little long, but its job is simple: to keep watch over the sky and spot celestial bodies that could pose a threat to Earth. Imagine a line of automated telescopes in Hawaii, Chile, and South Africa, scanning the heavens every night like diligent sentinels. They capture hundreds of images and compare them continuously to find any points of light shifting against the fixed background of stars. Most of the time, these turn out to be near-Earth asteroids. But once in a while, one of those faint dots turns out to be something entirely different. On a July night in 2025, one of these telescopes, located in Chile's Atacama Desert, happened to record such an object. At first, it looked like nothing more than another faint speck, indistinguishable from thousands of others the system routinely identifies. But when the data reached the Minor Planet Center in Cambridge, Massachusetts, astronomers immediately noticed something odd. The light was moving quickly, on a strange trajectory unlike anything in our solar system. After hours of calculations, the conclusion shocked the astronomy community. This wasn't a familiar resident of the sun's neighborhood, but a visitor from beyond. And it wasn't just Atlas that caught it. In the following weeks, scientists combed through older data and found that the object had already slipped into the frames of other observatories, though no one had paid attention at the time. Even NASA's TESS satellite, designed to hunt exoplanets by tracking the light of distant stars, had accidentally recorded Atlas's journey. When pieced together, these images showed the object had been drifting into the solar system for months before its official discovery. Like detectives sifting through old case files, astronomers retraced its path, bringing the bigger picture into focus. What makes this even more striking is how different the outcome would have been just a few years ago. When Oumuamua appeared in 2017, we only noticed it after it had already passed closest to the sun, leaving us with nothing but a fleeting glimpse. In 2019, Borisov gave us more time, but still not enough for a fully coordinated observation campaign. Both visitors departed too quickly, leaving behind more questions than answers. But by the time Atlas entered the stage, humanity was better prepared. Networks like Atlas and Pan-STARRS, combined with powerful ground and space-based telescopes, have turned discovery from a game of chance into a systematic process. If Oumuamua was like a startling phone call and Borisov a long letter from a distant friend, then Atlas feels like a detailed diary sent from the dawn of the galaxy. From the moment it was spotted, dozens of observatories around the globe followed it. Hubble, with its sharp vision above Earth's atmosphere, captured the clearest images of its shape and activity. TESS provided archival data, extending the observation timeline by months. The Rubin Observatory in Chile, still in its early testing phase, also managed to capture Atlas. It was a reminder that a new era of astronomy is opening, one where cosmic strangers are no longer rare surprises, but events we can expect to witness regularly. The international cooperation surrounding Atlas may be just as important as the discovery itself. From South America to North America, from Europe to Asia, telescopes everywhere locked onto the same faint speck. Data was shared almost in real time. Scientists refined its orbit, analyzed its spectrum, measured its speed together. Never before had an interstellar object become the focus of such a rapid, coordinated global effort. If Oumuamua stunned us, Atlas transformed that astonishment into an organized scientific project, a testament to what humanity can achieve when united by a common goal. The difference, though, lies in Atlas itself. Unlike the brief shadow of Oumuamua, this object was brighter, larger, more active. That gave us the chance to study it in detail as never before. Spectra revealed jets of water vapor and dust, clear signs of an ancient comet. For the first time, humanity had the opportunity to directly observe an active comet from another star system. Borisov was a comet too, but far dimmer and less revealing than Atlas. In a sense, Atlas is like a natural laboratory passing by, carrying the raw ingredients from the galaxy's earliest days. What makes the story even more fascinating is how technology has reshaped our role, from lucky bystanders to systematic hunters. Automated telescopes like Atlas don't need scientists watching every night. They work like cosmic scanners, snapping thousands of images and letting software highlight anomalies. Satellites like TESS, built for other missions, end up providing invaluable side data. Hubble, even after 3 decades, still delivers unmatched clarity from orbit. And Rubin Observatory, with its wide view and unprecedented sensitivity, promises that finding interstellar objects may become routine in the coming decade. But perhaps the most important point is this: discovering Atlas wasn't just a triumph of technology. It was a sign that humanity has entered a new phase in how we approach the universe. In the past, we had to wait for luck. Now, we know how to prepare. Atlas arrived at a moment when our tools were finally ready to track it from beginning to end, to not only marvel, but to record, analyze, and learn. It was as if the universe had sent us a test, and this time, we passed. So when we talk about Atlas, we're not just telling the story of a strange comet. We're also telling the story of how humans learned to guard the skies, from small telescopes to global networks, from satellites above Earth to the giant observatories of tomorrow. Atlas is proof that human curiosity, when combined with technology and international collaboration, can transform specks of cosmic dust into vivid chapters of history. And in each chapter, we discover a little more about ourselves, about our endless desire to know how the universe began, and how many other travelers may still be out there, waiting to be seen. When a stranger knocks on the door of our solar system, the first question astronomers ask is always the same: where did it come from, and where is it headed? Since they can't ask the visitor directly, they have to read its cosmic passport. That passport is the orbit. Hidden in the path of every celestial body is the story of its origin and its fate, a signature that can't be forged. For most things we know in the solar system, orbits take the shape of ellipses, held tightly by the sun's gravity. Earth, for example, has been circling the sun in a nearly perfect ellipse for billions of years. Comets do the same, though their paths may stretch farther and warp more dramatically, but they always close back in, returning after tens of thousands of years. But there's a special threshold. When the orbit bends so far, it becomes a parabola. That's the tipping point, where an object has just enough energy to escape the sun forever. Crossing that line is already rare, Beyond that, if the orbit becomes hyperbolic, it means the object isn't just escaping. It came from outside, with a velocity the sun can never capture. That's exactly the case with 3I Atlas. Calculations show Atlas has an eccentricity of about 6.14, far beyond any known interstellar visitor. Oumuamua's orbit was only 1.2, Borisov's was around 3.6. Atlas is nearly twice that, which means it's not just passing through, it's barreling along with immense energy. To picture it, Oumuamua traveled at about 26 kilometers per second, Borisov at 32. Atlas is tearing across space at 58 kilometers per second relative to the sun. That's fast enough to cover the length of nearly 600 football fields in a single second. No mechanism inside the solar system can account for such a number, not even with every gravitational slingshot from the giant planets combined. Its origin must lie far away, where violent encounters in another star system flung it into the path we now observe. But speed isn't the most startling thing. What surprises many is its direction. If the universe were like a vast airport, Atlas chose a flight path almost exactly along the ecliptic plane, the highway where our planets line up. Its tilt is only about 5 degrees off the plane traced by Earth, Jupiter, Saturn, and the others. Statistically, the chance of a random interstellar object entering with an orbit so closely aligned is about 0.2%. In other words, it's rare enough to make scientists pause and ask, is this just coincidence or something more deliberate? That's where the debate ignited. One camp takes the cautious view, arguing that the universe is so vast that even the rarest outcomes eventually happen. If trillions of objects have been ejected from star systems over the history of the Milky Way, sooner or later one will cut across the ecliptic just by chance. After all, stars and their planets often form in flat planes, and those planes are themselves usually aligned with the disk of the galaxy. So it's not unreasonable that many ejected objects would fly along similar paths. This is the reasoning of astronomers who put their trust in statistics and probability. But another camp, led by Avi Loeb, insists we shouldn't be too quick to dismiss extraordinary possibilities. Loeb, who previously stirred controversy by suggesting Oumuamua might be artificial, argues that Atlas's orbit looks intentional. If a civilization wanted to survey the solar system, they wouldn't choose a random tilted trajectory that misses the planets. They'd choose a path along the ecliptic, where the planets are. And by coincidence or not, that is exactly what Atlas is doing. From this perspective, its orbit looks like a carefully planned flyby, brushing past major worlds like Jupiter and Mars, as though conducting a detailed inspection. So where's the line between rare but natural and so rare it needs another explanation? When a 1 in 500 event happens, do we call it a miracle worth pondering? Or just one of the countless long-shot outcomes that time eventually delivers? That tension is at the heart of the Atlas debate. Adding to the intrigue is the idea of a hidden rendezvous. According to its projected orbit, Atlas will reach perihelion, its closest point to the sun, at the end of October 2025. From Earth's perspective, it will pass directly behind the sun for weeks, invisible to ground-based telescopes. For those entertaining the artificial probe theory, this looks like the perfect window for a maneuver, a kind of reverse solar brake that could transform an escape path into a captured orbit, turning Atlas into a hidden satellite of the sun. For skeptics, though, this is nothing but another coincidence, a natural consequence of geometry when any object happens to swing by the solar system. The truth will only be clear when Atlas emerges from behind the sun in December. If its trajectory matches predictions exactly, it will confirm the natural object explanation. But if there's even a slight deviation, the kind of course correction only propulsion could achieve, then the probe hypothesis gains weight. Astronomers are preparing to watch with every tool available, from space telescopes to spacecraft in favorable positions like Juno and JUICE, to track Atlas during the blackout. Whatever the outcome, Atlas's orbit is already a cosmic epic. It reminds us that the universe constantly throws fragments of distant star systems our way, while also hinting there could be something more, something intentional. Perhaps it's just a lost pebble drifting through space, or perhaps it's a faint postcard from an intelligence far away. Either way, while we wait for answers, Atlas is a reminder that in the scale of the cosmos, every curve, every number, every orbit can become a philosophical question about our own existence. If the orbit of 3I Atlas is its passport, then its shape and physical traits are the portrait, revealing the personality and history of this ancient wanderer. When humanity first turned its telescopes toward it, no one expected something small, because visitors from beyond the Milky Way tend to arrive in modest forms. Oumuamua, the first, stretched less than half a kilometer, a slender shard like a fishbone left behind on the cosmic table. Borisov, which appeared 2 years later, had a nucleus smaller than an Arctic iceberg. But Atlas, by current estimates, spans several kilometers across. In the depths of space, where size and mass dictate survival over billions of years, that makes it a giant compared to its predecessors. When sunlight strikes Atlas, something extraordinary happens. Instead of merely reflecting light like a frozen rock, it begins to evaporate. Hundreds of tons of ice, locked away since the dawn of the galaxy, are set free as vapor and dust. These streams erupt into a tail stretching hundreds of thousands of kilometers, always dragged opposite the sun. It behaves like a comet, but the thrill for scientists is this. For the first time in history, we're witnessing an active comet from another star system. No longer a silent rock, no longer a debated shadow, Atlas is alive, turning itself into a natural experiment, exposing its past in every particle it releases. Spectral readings from giant telescopes reveal the composition of that dust and gas. There's water, carbon monoxide, and signs of complex organic molecules, chains that may date back to when the universe was only a few billion years old. Strikingly, its spectrum glows a deep red, similar to distant comets from the Oort cloud, yet darker, as if countless millennia of cosmic radiation had tanned its surface permanently. Red is the color of blood, the color of sunset, and here it is the color of age, a sign that Atlas has endured a journey longer than any object we've ever studied up close. When Hubble turned its lens toward Atlas, the images were stunning. From millions of kilometers away, it was only a point of light, yet Hubble's sensitivity revealed the faint, fragile tail and brightness variations hinting at its outbursts. The James Webb Space Telescope, armed with infrared instruments, dug deeper, detecting organic gases and confirming that Atlas is more than frozen ice. It carries molecules that could form the foundations of life. Even Swift, a telescope designed to study gamma rays, joined in, capturing the shifts in dust output in ultraviolet light. On Earth, massive observatories like Gemini and the Very Large Telescope focused on Atlas, collecting high-resolution spectra. Each absorption and emission line was like a message written in light, helping scientists identify which molecules were escaping its surface. And perhaps most remarkably, amateur astronomers also added their brushstrokes to this portrait. With telescopes only 30 or 40 centimeters across, they captured the faint, glowing tail and shared their images across global forums. For the first time, photos taken in backyard gardens in Europe or North America were placed side by side with data from billion-dollar facilities, all contributing to the same grand mosaic. The internal structure of Atlas can only be inferred indirectly, but its eruptions offer clues. When a comet vents water vapor, it often exposes pockets of primordial ice. The flicker in its brightness suggests Atlas rotates unevenly, like a misshapen fragment rather than a neat sphere. This fits the idea that it is debris from the birth of a planetary system, broken apart in collisions and ejected into interstellar space. Inside, tiny ice grains are mixed with dust and organics, all frozen more than 10 billion years ago, untouched until now. In other words, it is a cosmic freezer, storing the raw recipe for planets, and perhaps even life. Scientists pore over every particle, every flicker of light, knowing Atlas offers a rare glimpse of pristine matter from beyond the solar system. Some grains of dust are large enough to drift into Earth's atmosphere, igniting as fleeting meteors. In the years to come, someone may look up and see a brief streak across the sky, never realizing it wasn't born of our sun at all, but a gift from a distant, long-vanished star. The portrait of Atlas is not just data. It is the story of a living traveler. It is immense, fiery red, erupting with the ingredients of worlds. It is alien, coming from a system that may no longer exist, yet familiar, carrying the very stuff that built Earth and humanity. In its crimson glow, we glimpse both the echoes of an ancient past and the clues to the question of life in the cosmos. If Oumuamua was a ghost and Borisov a whisper, then Atlas is the first full face we've ever been able to see, a grand portrait painted in light and dust. And that portrait will haunt our imagination long after Atlas has vanished back into the shadows of the galaxy. When we look at 3-Eye Atlas, we're not just seeing an object streaking across the sky, we're opening a doorway into the Milky Way's own past. Every number tied to its speed, every calculation of its orbit, is a fragment of a vast time machine, carrying us back to an era when the universe was still young. Atlas isn't simply an ancient comet. It may have taken shape before Earth and the Sun even existed, holding secrets from a time no human eye could ever have witnessed. To trace the origin of an interstellar visitor, astronomers start with motion. Atlas races along at about 58 kilometers per second, fast enough to escape the gravitational pull of the solar system. But speed alone isn't the key. Direction matters more, because that's what reveals where it came from. By rewinding its orbit, scientists can chart its path back millions, even billions of years. The uncertainty grows the further they go, but one trend stands out. Atlas doesn't appear to come from nearby young stars. Instead, it seems linked to a special region of the Milky Way called the thick disk. The Milky Way is a complex structure, but you can picture it as a giant disk with spiral arms. Inside that disk are two main parts: a thin section where the sun and most young stars live, and a thicker, older section filled with stars born in the galaxy's earliest days. The thick disk contains stars roughly 7 to 11 billion years old, which means they formed when the Milky Way was only about half its current age. These stars are metal-poor, meaning they lack heavy elements like iron, silicon, and carbon, which are produced in multiple generations of dying stars. That's why finding a comet from this region is surprising. It suggests that planet and ice body formation may have started much earlier than we assumed, even when the raw ingredients were scarce. Think of the universe as a kitchen. In the beginning, the pantry was bare, stocked only with hydrogen and helium, the salt and water of cosmic cooking. To make something complex like a planet, you need more: carbon for sugars, oxygen for water, silicon and iron for the foundation. The first stars exploded like clumsy chefs, scattering these ingredients across the kitchen. After a few rounds of this, the pantry grew rich enough to produce diverse cosmic dishes. In the usual picture, planets could only form once the shelves were well stocked. But Atlas is like an ancient bread baked when the pantry was still nearly empty, proving that the recipe for worlds might not need much more than a spark of creativity. With an estimated age of 7 to 11 billion years, Atlas could predate our solar system entirely. The Sun is only about 4.6 billion years old, yet Atlas may have been wandering the galaxy 2 or even 3 times as long. It has witnessed more than any planet we know. When it formed, Earth didn't exist, Saturn had no glittering rings, and the Sun was still just a collapsing cloud of gas. Atlas has drifted past supernovae, crossed dissolving star clusters, survived gamma-ray storms, all while keeping its ancient ices intact. That makes it one of the oldest witnesses we can study directly. Most of what we know about the early Milky Way comes from spectroscopy of old stars, but stars evolved dramatically, burning through hydrogen, helium, and beyond. A comet like Atlas, however, remains almost untouched, a sealed time capsule from the beginning. As it vents gas and dust, we're literally seeing matter unchanged for billions of years, a primordial archive offering data even the oldest stars can't provide. The biggest implication is this: if Atlas truly formed in such a metal-poor environment, then icy planets and comets could have appeared much earlier than we thought. That means the building blocks of life, water, carbon, organic molecules, were present in the galaxy from the very beginning. If life anywhere needs billions of years to evolve, those ancient worlds had plenty of time. Entire civilizations could have risen before Earth even formed, only to vanish or surpass us long ago. The simple fact of Atlas's existence reshapes how we think about that possibility. For centuries, people imagined the universe unfolding in a strict order. First heavy elements, then planets, then life. Atlas breaks that mold. It shows that even in scarcity, nature finds ways to build. Like an artist painting with only 2 or 3 colors, but still creating a complete canvas, the universe shaped Atlas and its kin long before the galaxy was rich in elements. They became vital pieces in the grand puzzle of world making. So Atlas isn't just another comet passing by. It's living proof that the universe had the ingredients for life very early on. It reminds us that life doesn't need a perfect kitchen to begin. Sometimes a few sparks are enough to ignite the long journey toward consciousness. Looking at Atlas, we don't just see the past, we glimpse the possibility that life elsewhere might have started when the universe was young, thriving in places we've never imagined. In that moment, Atlas becomes the greatest time machine humanity has ever touched. It carries us back to a young Milky Way, when stars were sparse, metals were rare, and worlds were still in the making. It reminds us that we, sitting here pondering origins, are latecomers in a story that began far earlier than we believed. And as Atlas drifts away, leaving behind only a fading red trail, we know we've just glimpsed a memory the galaxy itself has nearly forgotten. Throughout the history of science, whenever the universe has sent us a puzzling object, human imagination has erupted. 3 Atlas, with its strange orbit, unusual size, and baffling behavior, is no exception. When the first measurements were released, a question quickly took shape and spread. Could this be an alien probe, a device launched by a distant civilization, rather than just another lifeless comet? One of the people who fueled this debate is Avi Loeb, a Harvard astronomer well known to the public. Back in 2017, he made headlines worldwide when he suggested that Oumuamua, the first known interstellar object, might have been a light sail from an extraterrestrial civilization. That claim was met with fierce criticism, but it opened a daring line of thought. Maybe we shouldn't assume every strange object is purely natural. With Atlas, Loeb and a handful of colleagues are asking again, if it's just an ordinary comet, why does it break so many patterns? The first red flag is its orbit. Atlas travels almost parallel to the ecliptic plane, where most of the planets lie. The odds of a random object naturally falling into that path are vanishingly small, less than 0.2%. From Loeb's perspective, if a civilization wanted to survey our solar system, this would be the exact route to take, since it allows close passes by major planets without needing constant course corrections. Random chance or deliberate choice, that's the crux of the debate. The second oddity is its size. Oumuamua measured just a few hundred meters long, Borisov about 1 to 2 kilometers, but Atlas is estimated to span several kilometers in diameter, far larger than the others. An object that big isn't just easier to track, it could also hold more material, or even technology, if the artificial hypothesis holds true. Then comes the suspicious timing of its journey behind the sun. When Atlas reaches perihelion in late October 2025, it will disappear into a zone completely hidden from Earth-based telescopes for weeks. According to some speculations, that would be the perfect window for a secret braking maneuver, turning its escape trajectory into a bound orbit around the sun. Using the sun itself as cover feels, to some, like too perfect a coincidence. There's also the spectral data. Light from the dust and gas released by Atlas doesn't quite match that of ordinary comets. The ratios of compounds, the strength of absorption bands, the evaporation patterns, none fully line up with standard models. For Loeb and those who share his view, such anomalies could reflect exotic materials, perhaps alloys or engineered substances. Still, the mainstream scientific community has pushed back hard. Most astronomers agree the oddities are real, but insist they don't justify leaping to an alien explanation. Occam's razor has been invoked again and again. When multiple explanations exist, the simplest, most natural one is usually correct. In this case, natural explanations are still sufficient. A rare orbit? Given the trillions of objects in the universe, some were bound to wander near the ecliptic by chance. An oversized body? We've only seen 3 interstellar objects so far, hardly enough to know what normal looks like. The sun's shadow? Just orbital mechanics at work, with no evidence of steering. Strange spectra? Each star system forms under different conditions, so its comets could easily carry unfamiliar chemistry. These rebuttals don't dismiss the possibility of extraterrestrial intelligence outright, but they stress the need for caution. If every anomaly is instantly labeled alien, science becomes science fiction. On the other hand, if we never dare to ask bold questions, we may miss the greatest discovery in human history. That tension between skepticism and imagination is exactly what Atlas embodies. And the truth is, the scientific value of the debate doesn't depend on what Atlas actually is. If it's just an ancient comet, the arguments and counter-arguments still deepen our understanding of cosmic matter. If it's something stranger, we've opened a new path. Either way, science moves forward, because science isn't just a catalog of answers. It's the ongoing act of asking questions, sometimes the boldest ones. Seen from another angle, Atlas is a test of humanity. Faced with a mystery, how do we respond? Some rush to label it, others retreat into extreme skepticism, and in between are those willing to hold both possibilities at once. That balance is the strength of science. It isn't a single voice, but a chorus of perspectives, sometimes clashing, always converging on truth. The arguments around Atlas echo the days of Galileo, accused of making things up when he pointed out Jupiter's moons, or of Copernicus, when the idea that Earth orbited the sun was dismissed as absurd. Every leap forward in science has required someone daring to ask the improbable, and a community disciplined enough to challenge that idea with evidence. In that sense, Atlas is more than a comet. It's a mirror of how humanity confronts the unknown. So in the end, is Atlas really a probe from a distant civilization? Maybe, but the odds are so slim that most scientists say no. Yet the fact that a few are willing to say yes is what makes the story compelling. It reminds us that science isn't a closed system, but a continuous dialogue between curiosity and evidence. Sometimes, simply having the question matters more than the answer. When Atlas finally fades back into the darkness of the galaxy, it may leave nothing more than a dust trail, some spectral data, and a few hundred research papers. But in our minds, it will leave something far greater. The memory of a moment when humanity stood at the crossroads of reality and speculation, of nature and intelligence, and dared to ask, are we truly alone in the universe? In an age when news can spread across the globe in just a few hours, an object arriving from beyond the solar system was destined to become the center of a media storm. 3I Atlas, with its strange trajectory and speculation about being an alien probe, was thrust into that storm like an unwilling star. In laboratories, it was the subject of precise measurements and spectral charts, but in the headlines, it quickly transformed into a symbol of mystery, a half-real, half-mythical story the public couldn't look away from. The moment Avi Loeb and a handful of scientists mentioned the possibility of it being artificial, major outlets jumped on the headline. Did aliens just send a probe to check us out? Appeared everywhere, from popular science magazines to primetime television. For many journalists, it was a golden opportunity to pull in readers. The story of an ancient comet cutting across the solar system was already fascinating, but add the word alien, and it became global breaking news. Editors understood that no matter how cautious the scientific community was, the public craved something more dramatic than cold data. That exaggeration was both troubling and inevitable. Troubling because it risked turning serious hypotheses into entertainment. Inevitable because for thousands of years, humans have been captivated by the question, are we alone in the universe? Atlas, even if it was nothing more than a lump of ice, became the spark that reignited that imagination. Social media amplified the effect 100-fold. A handful of tweets, TikToks, or YouTube videos could send wild theories racing across the world. Some creators declared Atlas was definitely a scout ship. Others built elaborate 3D renderings of a spacecraft plunging toward the sun, and some even tied it to old UFO legends on Earth. At the same time, amateur astronomers used the buzz as a chance to explain concepts like hyperbolic orbit, escape velocity, or spectral analysis. What made it fascinating was that serious science and conspiracy theories grew side by side, flowing through the same channels of information. Caught in the middle of this whirlwind, the amateur astronomy community emerged as a surprisingly important force. They didn't have multi-million-dollar telescopes, but they had passion and a global network. With nothing more than a mid-sized telescope set up in a backyard, they could capture Atlas's faint light and share the images on worldwide forums. Composite photos from the US, Europe, Japan, and even small observatories in South Africa or South America circulated online, racking up hundreds of thousands of views. To the public, seeing everyday people photograph a visitor from beyond the Milky Way made it feel personal, turning Atlas from an abstract lab subject into something anyone could be part of discovering. Many professional scientists saw this as a positive. They knew that community involvement, even mixed with confusion and conspiracy, still carried huge educational value. A teenager stumbling across a TikTok might hear the term ecliptic plane for the first time. An older reader clicking on a sensational article might feel compelled to learn the difference between a comet and an asteroid. Debate, exaggeration, and curiosity pulled astronomy out of academic halls and into daily life. But the line between science and conspiracy is thin. While some science communicators worked hard to clarify the facts, UFO-focused YouTube channels used Atlas to bolster claims that the government is hiding the truth. These conspiracy narratives spread much faster than careful scientific analysis. That's the rule of information. Dramatic stories are always more appealing than charts and equations. It also forces the scientific community to adapt, to learn to tell better stories so the truth doesn't get buried under layers of speculation. Another unexpected outcome was cultural. Atlas inspired art in ways no data chart could. Electronic musicians, digital painters, and multimedia artists drew on the wanderer from beyond the galaxy as a muse. In contemporary art exhibits, fiery red comets streaking across the sky became metaphors for humanity's own drift through the cosmos. Science fiction writers rushed out short stories imagining Atlas as a probe leaving cryptic messages for humankind. In art, there's no need to be right or wrong, only evocative, and Atlas did that effortlessly. So what did the media storm around Atlas ultimately give us? On one hand, confusion and the seeds of conspiracy. On the other, millions of people suddenly exposed to astronomy, even in the simplest ways. For many, it was the first time hearing the phrase hyperbolic orbit, the first time realizing a comet could come from outside the solar system, the first time learning that light can be broken into spectra to reveal its chemical makeup. In a world flooded with fleeting entertainment, the fact that millions of people were debating these concepts at all was already a small victory for science. In truth, Atlas was both an astronomical object and a social mirror. It showed how humans react to a mystery. Imagination surges, conspiracies multiply, science strives to explain, and art finds inspiration. All of it weaving together into a chaotic, living mosaic. And within that chaos, knowledge still seeped through, planting seeds of curiosity that might one day lead someone down a serious path towards science. History shows that every unusual astronomical event comes wrapped in myth. Halley's Comet was once seen as an omen of war, eclipses as signs of divine anger. Today, we no longer live in an age of omens, yet we still hunger for stories tied to the sky. Atlas was simply the latest chapter in that tradition, and when it finally drifts away, fading from sight, the stories will remain, etched into our collective memory, as a reminder that the universe isn't just observed through telescopes, but also imagined through the minds of millions. Every journey has its defining moment, and for 3i Atlas, that moment will arrive on October 30th, 2025, when it swings past the sun at perihelion, its closest approach. In the language of astronomy, perihelion is a familiar term, but this time it has become the focal point of global anticipation. For it is there, under the searing heat and immense pull of gravity, that Atlas will reveal secrets it has kept for more than 10 billion years. Picture the scene, an ancient red block of ice plunging toward our star. Its surface boiling, jets of vapor and dust shooting out in plumes hundreds of thousands of kilometers long. Sunlight, already blinding, scatters across that expanding cloud, transforming Atlas into a glowing arrow streaking through space. But this is more than a spectacle. It is one of the greatest natural experiments humanity has ever witnessed. In the coming weeks, every question, whether Atlas is merely a comet or something more, whether its orbit shifts unexpectedly, whether its chemistry hides something strange, will be put to the test. To prepare, scientists have organized an unprecedented global observation campaign. The James Webb Space Telescope, with its infrared eyes that can pierce through dust, will monitor the gases and organic compounds evaporating from the surface. Hubble, though aging, still has the power to capture sharp images in visible and ultraviolet light. Even Swift, built to chase down gamma-ray bursts, will point its instruments at Atlas in the ultraviolet, providing another layer of data on cometary activity. Spacecraft across the solar system will also take part. Juno, orbiting Jupiter, and JUICE, en route to its icy moons, will have chances to aim their instruments at Atlas. Even the orbiters around Mars may catch glimpses, offering perspectives Earth cannot. Back on the ground, observatories from Chile to Hawaii, South Africa to Europe, and Japan will all turn their telescopes skyward. Never before has an interstellar object been tracked with such intensity. All of this builds toward a pivotal moment. What happens when Atlas disappears into the sun's glare, only to reemerge in December 2025? That is when the probe hypothesis faces its hardest trial. If Atlas is just an ancient comet, its orbit will match predictions exactly. But if there are any deviations, if it slows, shifts, or turns, then the story takes a very different turn. Scientists have prepared countless models for comparison, where even a single pixel of data could become evidence. This may be the most rigorous test of an extraterrestrial hypothesis ever attempted. Yet this journey isn't reserved for scientists alone. The public is invited too. Online tools like JPL Horizons let anyone, from a high school student in Asia to a journalist in Africa, track Atlas's orbit in real time. Sky mapping websites allow users to find its position as though they had their own telescope. Live streams from observatories will beam the encounter directly to millions, turning a scientific event into a global festival. Perihelion is more than a scientific trial. It's an educational opportunity on a planetary scale. As people follow Atlas, they learn how to read orbital graphs, what a hyperbolic path means, why splitting light into a spectrum can reveal the nature of matter. Every article published, every explainer video uploaded, brings new minds into contact with knowledge they may never have sought before. Like eclipses or Halley's Comet in centuries past, Atlas could open a door to cosmic curiosity for millions. And yet, beneath the excitement, there is a tension. This is a once-only chance. If we miss key data during the days Atlas swings close to the sun, there will be no second opportunity. It will speed back into interstellar darkness, leaving only memory behind. Scientists must plan every detail, observing schedules, instrument calibrations, data pipelines. A sudden solar storm could scramble communications. A minor technical fault could cost us irreplaceable treasure. Atlas is a fleeting guest, and we have only a short time to ask our questions. At a deeper level, the perihelion challenge carries a symbolic weight. It feels like a dialogue between humanity and the cosmos. We bring every tool, every ounce of intellect to study a small, icy traveler, hoping to learn a little more about our past and perhaps our future. Atlas, indifferent, follows its path, shedding dust and vapor as it goes. That indifference doesn't discourage us, it drives us. For within that silence lie mysteries still intact. When December arrives and Atlas emerges from behind the sun, millions of eyes will follow. Maybe we'll see nothing more than a comet continuing on its way, adding another piece of evidence to the universe's natural diversity. But perhaps a subtle shift in its path will rekindle the profound question of whether intelligence exists beyond Earth. Whatever the outcome, Atlas will have fulfilled its role, forcing humanity to confront its hunger for knowledge, the limits of its science, and the duty to capture every fragment of data so we never have to say, we missed it. In the future, generations may look back on Atlas's perihelion as a turning point. Not because it solved the question of alien life, but because it showed that humanity was mature enough to work together, to mobilize every resource, and to invite the world to share in the discovery of an interstellar wanderer. Proof that science is not the domain of closed labs alone, but a shared human journey, where every gaze, from giant telescopes to personal computers, joins together to follow a traveler passing once across the sun. If Three-Eye Atlas is just one gripping chapter in the cosmic novel, then the next chapter is already etched into the mountains of Chile, where a colossal project called the Vera C. Rubin Observatory is preparing to open the door to a new era. For astronomers, Rubin isn't simply a telescope, it's a revolution, a completely different way of seeing the sky. And for interstellar wanderers like Atlas, Rubin promises to turn what was once a rarity into a regular occurrence. The Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, has a special mission: to scan the entire southern sky every few nights. Instead of staring at a tiny patch like most telescopes, Rubin functions like a massive camera. Its 3.2 gigapixel sensor is the largest ever built, capturing images that cover thousands of square degrees of sky and recording tens of billions of stars, galaxies, asteroids, and of course, mysterious objects drifting in from interstellar space. The key lies in speed and repetition. Oumuamua and Borisov appeared almost out of nowhere, giving humanity only weeks or months to observe them. Rubin, however, won't miss a thing. With its relentless cadence, it will be able to catch faint specks of light just as they creep into the outer edges of the solar system. That means instead of stumbling across one interstellar visitor every few years, we could see dozens, even hundreds, in a single decade. This sheer number will transform the science. Instead of treating each object as a singular enigma, we'll have an entire population to catalog, compare, and draw patterns from. Imagine, instead of only 3 known examples, Oumuamua, Borisov, and Atlas, scientists suddenly having hundreds. Each one tells a small story, but together they piece into a sweeping panorama of how planetary systems form and evolve across the galaxy. Some may be ancient, reddened comets like Atlas. Some could be barren shards like Oumuamua. Some may be young comets with compositions utterly unlike Borisov. And some could be unlike anything we've ever imagined, with new shapes, trajectories, and chemistries. It's through that statistical lens that the big questions may finally find answers. Are comets and icy planets common across every star system, or do they form only under rare conditions? Are there regions of the galaxy where life is more likely to emerge, simply because icy objects carrying water and organics are more abundant? Most importantly, do interstellar visitors routinely crash into young planets, seeding them with the raw ingredients of life? Atlas alone can't tell us, but 100 Atlas-like objects over the next decade just might. Rubin doesn't just deliver data, it changes the way we approach knowledge itself. With its vast archive openly available, not only scientists but the public at large can take part. Students, independent researchers, even amateur skywatchers can sift through the data to find new worlds. In a sense, Rubin turns our entire planet into one shared telescope, where anyone can ask their own questions. That shift expands the frontier of science, making astronomy a collective journey rather than the pursuit of small, isolated teams. The impact reaches far beyond comets. Rubin will reshape planetary science as a whole. By identifying millions of asteroids and meteoroids within the solar system, it will sharpen our understanding of Earth's collision risks while also mapping the blueprint of how our system was built. And when those findings are set beside interstellar discoveries, we'll finally have a basis for comparison. Is Earth and our solar system truly special, or just one of countless variations nature has tried? But Rubin's deepest influence may be philosophical. Until now, each interstellar object has sparked worldwide headlines, labeled as an alien visitor, wrapped in debate and even conspiracy theories. In the Rubin era, such visitors will become so common they'll no longer feel like exceptions but expected features of the cosmos. Instead of asking, "Are we being visited?" we'll be asking, how many types of visitors are out there, and what do they reveal about life's origins? Science will move from isolated wonder to systematic study, from rare encounters to statistical abundance, from questions of chance to questions of pattern. In that sense, it marks humanity's maturity. No longer chasing each anomaly with half-belief and speculation, we'll be building an entire science of interstellar visitors. It's a transition as profound as the shift from ancient comet omens to Newton's orbital mechanics. Now we enter the era of interstellar statistics, where each object is not just a story on its own, but a data point contributing to a shared cosmic picture. And from there, the questions about life itself will come into sharper focus. If Atlas-like objects prove common, it means the processes that form comets and icy planets are widespread throughout the galaxy. If they all carry water and organics, then life isn't a cosmic exception, but a near inevitability. And if, one day, one of Rubin's countless discoveries shows anomalies beyond any natural explanation, we'll finally have the context to separate the ordinary from the extraordinary. In that way, the Rubin Observatory isn't just an instrument, but a bridge from Atlas to the future. It will turn rare events into continuous streams of data, transform scattered questions into systematic answers, and most importantly, keep feeding humanity's hunger to explore. Every image Rubin sends back, every new object it uncovers, is a reminder that the universe is larger than we imagine, and that in searching the skies, we're not just looking for answers, we're looking for ourselves. Looking ahead, it's clear that Atlas is not the end, but only the beginning. It's the prologue, and the Rubin Observatory will write the chapters to come. In that story, interstellar wanderers are no longer lone strangers, but a multitude of messengers, carrying signals from across the galaxy. And we, with our ever sharper technological eyes, will learn to listen to them all. As this imagined book comes to a close, we realize that 3i Atlas is not just an icy traveler passing through our solar system, but a layered story stretching from hard science to soaring imagination. The 9 chapters behind us are like 9 slices, each offering a different angle on this ancient visitor, together forming a wide mosaic of humanity's dialogue with the cosmos. We began with a sense of primal wonder. Atlas emerged like a ghost from the dawn of the Milky Way, carrying traces of a universe still poor in metals, a time when even the birth of planets seemed impossible. From that very moment, it was clear we were not looking at a mere comet, but at a witness, a time machine built of ice and dust. Then came the process of discovery, no longer a lucky accident like Oumuamua, nor the frantic chase of Borisov, but proof of how far modern observation has matured. The Atlas Network, Pan-STARRS, TESS, Hubble, Rubin Observatory, together they turned a faint blur of light into a global story. Here, science revealed itself not as the triumph of lone genius, but as the power of systems, international cooperation, and collective intellect. When we traced Atlas's orbit, we stepped into the cold but haunting world of numbers. A hyperbolic plunge, racing at 58 kilometers per second, its tilt nearly aligned with the ecliptic. Facts that whispered of random statistics while also stirring suspicion of intent. And here, science met philosophy. Is the universe only a game of probabilities, or do hidden intentions shape what we see? Light and spectra painted the portrait of Atlas. A body a few kilometers across, larger than any interstellar guest we've met, glowing red in sunlight, venting water and dust like a comet alive. Within each grain lay water, carbon monoxide, and primordial organics. In it, we saw something familiar, the echoes of comets in our solar system, yet also something foreign, a chemistry not quite our own. Atlas was at once kin and stranger. Tracing its origins led us back to the thick disk of the Milky Way, where ancient metal-poor stars gave birth to it 7 to 11 billion years ago. In that contrast, Atlas became proof that the universe could build even with meager ingredients. If a comet like this could form so early, perhaps life itself had chances to emerge long before Earth was even here. And so the alien question inevitably arose. Avi Loeb and colleagues dared to push past caution, suggesting Atlas might be a probe. The scientific community pushed back, invoking Occam's razor and natural explanations. But in that clash, science found vitality. Imagination stretching skyward, reason holding steady on the ground, both bound together in the pursuit of truth. Yet science no longer unfolds in quiet chambers. It plays out before the world. Media and social networks turned Atlas into a cultural star, where conspiracy theories and basic astronomy mingled. People made videos of alien spacecraft even as they learned the term hyperbolic orbit. Serious and playful, data and fantasy swirled into a global media storm. And the miracle was that even in the noise, millions touched science for the first time, and the sky no longer felt so distant. Then came the great test, perihelion, October 30th, 2025, when Atlas skimmed the sun and vanished behind its blazing shield. This was the moment when every idea, cautious or bold, would be put to the test. Space telescopes, spacecraft, ground observatories all trained their eyes. Around the globe, through JPL horizons and live streams, people watched together. Here, science was no longer the privilege of research institutes, but a community event, a global festival of curiosity. Looking ahead, Atlas is only the beginning. The Vera C. Rubin Observatory will turn rare interstellar visitors into routine ones. Instead of 3, we'll have hundreds. Instead of isolated surprises, we'll build a statistical map. And through that, the big questions about planet formation, about the distribution of water and organics, about life beyond Earth, will begin to find answers. Atlas opened the book, Rubin will write the rest. All of this reveals a simple but profound truth. an icy comet drifting in from the deep, can reshape the way we see the universe. It shows us that science is not just numbers, but the search for meaning within them. It shows us that media is not only noise, but also the gateway that lets millions step into the world of knowledge. It shows us that in the dust streaming off Atlas lies the history of the galaxy, the story of life, and a reflection of ourselves. One day, Atlas will leave, vanishing into interstellar night, never to return. But its fleeting presence leaves a lasting mark. It forces us to look back into deep time, to argue about possibilities that stretch imagination, to prepare for a future where interstellar discovery becomes ordinary. It reminds us that the universe is too vast to measure, and humanity too small to face it with anything but endless curiosity. In the end, Atlas is not just an object, it is a story, a metaphor for humanity's relationship with the cosmos. A story we ourselves write, chapter by chapter, with data, with hypotheses, with debates, with imagination, and with the longing for meaning. And as Atlas hurtles on, carrying its secrets into the interstellar night, it leaves us with a gift beyond measure. The certainty that we will never stop asking, never stop chasing faint glimmers on the cosmic horizon. Because within each question lies part of the answer to who we are.